EDC takes away the guesswork of formatting your own data requests. It eliminates the need to navigate the labyrinth of request protocols, output formats, and date-time standards necessary to access information via data services. It provides an easy-to-use Java interface for subsetting and downloading data, making sure you get only what you need. EDC automatically detects the software package from which it was launched and downloads data in a compatible format.
The EDC can be used to connect ArcMap to a number of different data services. In this tutorial, we're going to see how to use EDC to connect to a Threads data server. Go ahead and launch the EDC application using the Environmental Data Connector option from the EDC menu. This launches a Java application, which allows you to connect to a Threads data server. You can choose an existing Threads data server from this drop-down list, or type in a new address. Once you've got the URL that you're interested in, go ahead and click the Connect button, and the data available from that data server will be displayed here in the left-hand pane. By expanding these folders and drilling down to the datasets and clicking on a dataset, I can see the metadata for that dataset here in the right-hand pane. Once I've determined the dataset that I'm interested in downloading, I can go ahead and click the Subset and Process button. In this case, I've chosen the vCurrent components. What I want to do before subsetting that data is go ahead and add the U components. So at the top of the box here, I'm going to click Add Dataset and choose the dataset that contains the U components. Back in the Subset and Process window, the first thing I want to do is subset my data based on my area of interest, which in this case is going to be the Channel Islands region of California. I'll go ahead and zoom into that region, and then click the Select by Bounding Box option and draw my bounding box on the screen. The next thing I'm going to do is request that I want feature data to be downloaded to my computer, and then I'm going to go ahead and choose my variables, which are the U and V components. I want that feature data to be drawn as vectors. I'm going to go ahead and choose the As Vectors option, and then set my U and V components correctly here. The last thing I'm going to do before downloading data is set my time frame of interest, which in this case is going to be the spring of 2007. I can change my time frame by using these little buttons that can be clicked and dragged. Once I'm happy with the way that I've subset my data, I can go ahead and click the Process button, and I'll be prompted to save the file locally. EDC then makes a request to the Threads data server using all the parameters that I specified, and downloads a .NETCDF file locally, which is then converted into a feature class. Once the conversion occurs, the vectors are displayed in ArcMap, and using the custom EDC time slider down here at the bottom of the screen, I can go ahead and animate those over time. Now we're going to add some sea surface temperature data to our map by connecting to an ERDDAP data server. I'm going to go ahead and open up the EDC GUI again using the EDC menu option. In this case, we're going to choose the ERDDAP server connection and click Connect. Just like with a Threads server, all the available datasets are displayed in the left-hand pane, and clicking on any of the datasets allows you to see the metadata in the right-hand pane. Since we know we want MODIS sea surface temperature data, we're going to go ahead and use the search term MODIS to see what is available. And from our available options, we're going to click the 8-day composite of MODIS data. Because this data set is gridded data, the grid data option at the bottom of the GUI becomes activated. Clicking that button is going to bring us to the same subset and process pane as we saw when we used the Threads data. We're going to go ahead and navigate to the same area of interest. And again, we're going to set a bounding box around the Channel Islands area of California. We're going to choose sea surface temperature as our variable, but this time we're going to choose to download the data in raster format. Since we're interested in spring and summer of July 2007, we're going to go ahead and choose that time frame using the calendar controls this time. Now that we have our area of interest, our time frame of interest, and our variables set, we're going to go ahead and click the process button. And again, we're going to be prompted as to where we want to save that data set locally. And then EDC is going to make a request to the ERDDAP data server using the parameters of our choosing and download a .netcdf file locally to our computer. Once that file gets downloaded, ArcMap automatically converts it to a raster file and loads it into the map. Go ahead and pull our current data set on top of our CService data set. And then as I start navigating forward through time, you can see those two data sets get animated together. Next, we're going to add some wind data from an NDBC buoy using an SOS connection. Again, we will launch the EDC GUI from ArcMap. The NDBC SOS URL is preloaded, so we simply have to choose the SOS option and click Connect. The GUI for requesting SOS data is different than threads in ERDDAP. Rather than choosing from a list of datasets, the sensors are drawn on a map. Once the map is loaded, you can navigate to your area of interest and select one or more stations by clicking on the map or using the bounding box. Once stations have been selected, choose from the list of available variables on the right side of the GUI. Finally, set your time range and then click the Get Observations button. A request will be made to the SOS server and your data will be downloaded as a CSV file that is automatically converted to a feature class. Once the feature class is loaded into ArcMap, it can be animated using the Time Slider tool. And the Time Series tool can be used to plot the data. The user simply has to set the date-time field and choose the variable of interest. Finally, we're going to connect to ERDDAP again and request some tabular data. After opening EDC and connecting to the Coastwatch ERDDAP server, we'll do a search for the word channel to narrow down the dataset listing. From the search results, we'll choose a dataset of fish transects. We know that this is tabular data because the TableDAP button is active. After clicking the button, we're brought to a subset and process window specific to TableDAP. We can still subset our data in space and in time and have a long list of variables to choose from. Required variables cannot be unchecked. Once we press the Submit button, our request is submitted to ERDDAP and the data is downloaded as a CSV to the local computer. ArcMap then converts it to a feature class where it can be displayed and animated with Time Slider.